The accessory gearbox provides the power for hydraulic, pneumatic and electrical systems which are used on both the engine and in the aircraft. The accessory gearbox is also used to drive fuel pumps, oil pumps and tacho generators and various other devices necessary for efficient engine operation. The drive for the accessory gearbox is usually taken from the high-pressure compressor shaft via an internal gearbox. The drive then passes to an external gearbox, which provides mountings for the accessories and also, in the majority of cases, the engine starter motor. This picture shows accessory mountings on an accessory gearbox which have been blanked off temporarily. In a modern turbofan engine, there is much less of a problem regarding where to fit the accessory gearbox than there would be in the case of the sleek slimline type of engine which might be fitted in a fighter aircraft. The turbofan engine itself is so massive that even the largest accessories can be fitted beneath the cowling that forms the air intake fairing. Axial movement of the compressor shaft would cause the teeth of the bevel gears to move apart and the drive would be interrupted. Momentary interruption of a drive transferring 400 to 500 horsepower would impart massive damage to the teeth of the bevel gears and probably destroy them. This state of affairs obviously cannot be allowed to exist. However, axial movement of the compressor shaft must occur due to expansion and contraction during the working cycle. Some method of arranging the gears so that they do not disconnect themselves because of axial movement of the shaft has to be found before a reliable drive unit can be manufactured. This diagram shows one of the methods currently in use to pass the drive between two shafts on modern engines. If the compressor shaft is splined, then a stub shaft, which has teeth cut internally that conform to the pattern of the grooves in the compressor shaft, can be fitted around the compressor shaft. The fact that the spline shaft can move axially while the stub shaft is held firmly in the correct position by the location bearing means that the gear teeth will not lose contact with each other. An alternative system to the stub shaft drive, which will allow the drive to pass between two shafts, uses an idler gear shaft, which is held firmly in position by location bearings. One end of the idler gear shaft terminates in a wide-toothed spur gear, which can accommodate axial movement of the compressor shaft and the spur gear carried on it, and the other end is fitted with a bevel gear, which meshes with the radial drive shaft. In an effort to spread the load of driving accessories, some engines divide the accessory gearbox into two smaller separate gearboxes. As well as the drive from the high-pressure compressor shaft, a second radial shaft is taken from the low-pressure compressor shaft, which is rotating at a slower speed, and used to drive a second external gearbox. This two-gearbox system has a second advantage of allowing the accessories to be divided into two smaller groups, thus overcoming the difficulties of limited space around the engine. During engine start, the starter motor, which is mounted on the accessory gearbox, normally driven by the high-pressure compressor shaft, has reversed the normal drive situation. Instead of the gearbox being driven by the engine, the gearbox is now the driving force on the engine. The starter motor thus causes the high-pressure compressor shaft to rotate, and the low-pressure compressor shaft is rotated subsequently by air being drawn through the engine. This generates a situation that requires that accessories which are specific to the engine's operational needs, such as the oil pumps and the fuel pumps, are grouped on the gearbox which is driven by the high-pressure compressor shaft. This gearbox is classified as being the high-speed external gearbox because it's being driven by the shaft which is rotating at the highest speed of all. Logically, the other accessory gearbox is called the low-speed external gearbox. Having to fit the gearbox around the engine means that the accessory gearbox must have a banana-like shape. For ease of access during servicing, the accessory gearbox is usually located on the underside of the engine. This picture shows an accessory gearbox and some of the associated accessories. Worthy of interest are the oil pumps, which are contained in an oil pump pack, a unit which contains one pressure pump and a number of scavenge pumps. In some engines, as many as 6 scavenge pumps may be contained in an oil pump pack. The width of the gear teeth in this gearbox indicates that the greatest load from driving the accessories is taken on the right side of the gearbox, while the thinner teeth on the left side gear wheels show that their load is much smaller. This grouping of small and large gears enables an efficient distribution of the drives for the minimum weight. Mechanical failure of an accessory could possibly cause the failure of the whole gearbox, and because the engine fuel and oil pumps are driven by that gearbox, the associated engine will fail. To prevent this happening, the mechanical equivalent of an electrical fuse is fitted to some of the accessory gearbox drives. A weak section is machined into the drive shaft. This weak section is known as a shear neck. The shear neck is designed to fail if it incurs a load which is perhaps 25% in excess of the normal maximum load for the particular component being driven by that shaft. In circumstances of excessive overload, the shear neck will break, allowing failure of the individual component, while the rest of the gearbox and accessories continue as normal. This feature is not utilized in the drives of primary engine accessory units, such as the oil pump pack or the engine high-pressure fuel pumps, because any failure of these components would necessitate the immediate shutdown of the engine. This concludes the lesson on gearboxes.